Okay, hey guys, we're going to look at 4C. 4C and 4D are calculator questions. Part 2 of the IB exam, part 2 and 3 are calculator questions. So the second it's a part 2 question, you take your calculator out. No one cares if you can do it without a calculator. That's part 1. I'll say it again. If it's a part 2 question, you use your calculators. Do not try to graph something in a part 2 question without a calculator. Okay? No one cares. No one cares that you can do the algebra on a part 2 question because you have a calculator. So you need to know how to use your calculator. So let's start. The idea is you're going to be asked to draw a graph of a weird looking function that maybe you've seen it, maybe you haven't, but it's part 2, so you use your calculator. Okay. What you're looking for are y-intercepts, which, where they cross the y-axis. You're looking for x-intercepts and the zeros. You're looking for maximums and minimums, and you're looking for asymptotes. Vertical asymptotes have restrictions on the domain. So let's take a look at some. Let's take a look at some of these. Well, let me read through. Vertical, there's restrictions on the domain, so certain x values that are eliminated. Horizontal asymptotes, if you see something raised to the negative power, or if the numerator is less than the order of the denominator, the horizontal asymptote, the function approaches 0. If the order of the numerator and the denominator are equal, then the horizontal asymptote is actually the ratio of the lead coefficients. We'll take a look at that in a second. And just a nota bene, NB, if the order of the numerator is greater than the denominator, then the function just goes off to the infinities. And when you are asked to graph, make sure you get the shape right and the identity, and identify all the above if it exists. So let's go over to Desmos, and whoops. Oh, come on. Oops, there we go. So, I guess am I here? Am I on the screen? Hopefully I'm here. So let's take a look at the first graph I identified, which was, here. So we see that if we look in the denominator, we see that x equals -1 and +1 are restricted from the domain, and we can see those are the vertical asymptotes. X equals 1 and x equals -1. Okay. The next graph I described was if we have 2 to the negative x, we see that if we have a negative exponent, it's getting smaller and smaller. It's approaching 0. Obviously, look for the plus c, the shift up and down. But in general, when you see 2 to the negative x, it's probably going to approach 0. And then the other example I brought up was when the denominator, we have a rational function. The denominator is the order of the denominator is greater than the numerator. Once again, because the denominator is getting so much larger than the numerator, it's approaching 0. The next example was when another horizontal asymptote is when we look at number 4, and we see that the order of the numerator and the denominator are the same, but the lead coefficient it's 3/1, and so obviously you can see the horizontal asymptote is y equals 3. My metaphor is like a horse race. The top is going 3x plus 1, the bottom is going x plus -7. That plus 1 and that -7 fade away when x starts approaching a million, a billion, a trillion. So you have the ratio of 3/1. It's never really getting there because the +1 and the -7 still kind of mess with that ratio, but it's getting really close. And then the last thing I spoke about was when the numerator, the order of the numerator is greater than the denominator, it's going off to the infinities. And we saw that with, you can see that in the graph. Let me take the blue off. You can see that in the graphs. And you can fool around with this. You can change this to A and change this exponent to B. Let's make a slider for all of them. And you kind of fool. You can see as A is greater than B, the function goes off to the infinities. But when B is greater than A, it just approaches it approaches the axes. You can see that. Okay, let me get rid of that. And okay, so let's get rid of this. Okay, let's go to the first example in the book. So the first example in the book is y equals x cubed minus 16x divided by x squared plus 1. Once again, you're not expected to graph this by hand, so don't. Get it on the graphing calculator and see what's going on here. So what's important? If I did a sketch, what are the important points? Well, you know that this is going off to the infinities. We can see that when we look for the y-intercept is 0, 0, right? We also and then the next one we can also see are some zeros. Negative 4, 0, 0, 0, and 4, 0. Actually, you could do that by hand. X cubed minus 16 equals 0, or you can use your graphing calculators to find the zeros. I'm not sure if everyone has a calculator, but we'll talk about that in a bit. The other thing I notice are these maximums, these turning points, and you're supposed to identify them the best that you can. This turning point is probably like negative 0.9, 7.55, and this turning point down here is also probably 0.9, negative 7.56. These are the things you identify in your graph. It doesn't have to be perfect. It's a sketch, but you're telling me the shape is important. You found the y-intercept, the x-intercept, any maximums and minimums, and any asymptotes. Good. Let's move on to the next graph in the book. The next graph they give you is y equals x times e to the negative x plus 2. Maybe you have an idea what's going on, but it's a part 2 question. Put it in the graphing calculator. So what's going on here? So you look at this and you're like, okay, that's kind of interesting. Maybe you zoom in, you zoom out. What you see here is it starts at like negative infinity. It comes up. You identify a 0. You're like, okay, there's a 0. You identify the y-intercept, and you see what's going on here. Like, oh, there seems to be a bump here. Well, there's a maximum. It kind of reached the max, and then it kind of comes down. I want to zoom in because I want to know what's going on. So use your graphing calculator to zoom in. Like, there's a max here. On your graphing calculator, you can actually zoom into the area and find the max. And the calculator will tell you the max is 1,2.37. Okay? The next thing we notice is that it's not going down to 0. It seems to be an asymptote. And zoom out, you say, oh, you know what? It's going to that plus 2. And you would identify that as a y asymptote. That's what they're looking for. Once again, it doesn't have to be a perfect sketch. It just has to look like it. And once again, you have to identify the shape, the 0, the y-intercept, and that turning point, and the asymptote. Last example, y equals ln of, open parentheses, absolute value of x minus 2. Maybe you think you know how to graph it. You're not sure. It's part 2. Put it on the calculator. I'm telling you this again. I don't care what you can do on a part 2 question. No one is impressed. No one cares. They're just giving you M1s and A1s. So let's take a look at this graph. Oh, that's kind of interesting. So let's see. First of all, it's the absolute. Let's interpret what's going on. It looks like, it doesn't look, we know logarithms they go off to infinity, right? So there's no upper bound. We know that from logarithms. It may look like it's an asymptote, but it's not, because as I keep zooming out, it keeps approaching 10. As I go to if I zoom out even more, now it's up. So the idea is that there's no asymptote. But what's going on it seems something's going on here. And we notice that we can't have 2 because we can't have the ln of 0. Now you might say, well, we can't have negative numbers, but if you notice, everything is absolute value. So it's like a reflection. So what you're going to do is you're going to look for the y-intercept, which is, what is the y-intercept? It's a 0.693. That's an interesting number, right? That's the ln of 2. Well, obviously, when x equals 0, we have the ln of 2. We're going to look for the zeros. X equals 1, x equals 3. And we see here that we can't have 2. That's also a vertical asymptote. Make the sketch, and you're done. And once again, have the shape, the y-intercept, x-intercept, the zeros, and the x asymptote, and you're done.